what's going on right now. So we are heading to the NASA Kennedy Space Center. We got the full FarmBot core team.
What are we getting into now?
And we're heading to an open source food workshop where we've been invited to figure out how to grow food in space.
So this is really exciting for us because we're starting to see our work be picked up by really renowned engineers and organizations such as NASA to solve really big challenges. How do we grow food in the International Space Station? How do we grow food on Mars? How do we grow food on the moon?
The big thing for NASA to be able to really go ahead and do this is collaborations. As we look down this timeline, think about some of the new things that are going on commercially in the world today, the things that Caleb's doing, Rory are doing, how they're trying to solve the food problems of the world, and how do we adapt that to what we're trying to do in space. Up until this point, within the agency, especially here at the Kennedy Space Center in the area that I work in, there has been a very traditionalized way of doing things. That tradition went from the Apollo program to the Space Shuttle program to the Space Station program. The open source community is really jump-starting and just fast-tracking ideas, and it's that aspect we really need to leverage on.
Caleb Harper from the Media Lab, a bunch of my homie nerd farmers in the space. We built this thing we called the food computer, and we put it out in schools. You know, this gave them a virtual environment, sensors, actuators. They could load a recipe, climate recipe grown by some other kid somewhere else.
So I'm going to go through kind of the story of how FarmBot came to be. We presented what we do at FarmBot, and we also heard what's happening at MIT, FIT, as well as Fairchild Gardens, New Harvest Group.
I think open source is a good way to solve big challenges because you have kind of the wisdom of a crowd instead of the wisdom of one person. And I think for problems that are as big as feeding the planet or figuring out a new system of agriculture, that we need to use the brains of so many different people in so many different disciplines. And open source facilitates that kind of sharing and collaboration much more easily than doing things in a proprietary way.
But if we could get the tour guides standing, maybe 2 at each door.
Blue group ready?
Yes. On the NASA facility tour, we got to see all the different laboratories where they're experimenting with different technologies for how to grow food in space.
The main focus of this room is for our technology infusion. So you can see the FarmBot machine here.
Not only did they have a FarmBot set up, but they also had a laptop with the user interface with code that I personally contributed. And knowing that their engineers and their team were using stuff that I was contributing was really amazing to me.
We also work in a lot of different technologies that we here at KSC find out about through going on the internet, talking to people, collaborations, etc., working with other aspects within NASA. We're basically trying to take the best ideas that are out in the commercial world and trying to see if there's applicability to use them for space flight. They've been working growing food in space for 35, 40 years. The people who've done all the background work, they're at the end of their careers now, so we're trying to bridge that gap. Really, now is the time to get infusion.
For me, and increasingly a lot of larger organizations, the whole open source thing is slowly becoming a no-brainer. You know, we're getting from a situation where there were tight intellectual property rules and you know, nobody wanted to share, nobody wanted to collaborate, and we're moving towards a better system where people are talking to each other. Instead of coming from this position of, you know, what shouldn't I say, you know, what's beneficial for me, we can take it from the stance of how can we help each other? What can I learn from them? What can they learn from me? It's a much better way not only to do business, but also research and just collaborate in general.
We also got to see the APH, which is the Advanced Plant Habitat, and it was very similar technology to what we have with FarmBot and what MIT is doing with the Food Computer project. So it's really cool to see how we're all tackling roughly the same problem, and there's a lot of overlap in how our technologies function and how what our vision is for the future.
Thinking of it from just as an example, the solution to Mars. So forgetting the names of all the players, right? This is a problem that faces humanity as a whole, right? Eventually we know that there's a limited number of resources here. Why would we want a handful of people to make all the decisions for what that looks like, right? Why not turn it back to the world and see what solutions can come from that, can be innovated from that, right? And I think this is actually one of the best examples of where something open to the world is going to be the best solution.
We are going
north for 4 miles.
We are going to OSB 2. the operations support building.
How big is it, Rory?
It's huge.
Fit it in the state here.
I wish they had bigger ones of these. Oh my god. Space walking glove oven mitts.
I think we should all get one. On sale, $19.95 at the gift shop.
During the rest of the event, we participated in breakout sessions where representatives from each of the groups, as well as NASA engineers and scientists, led discussions and little workshops discussing the various challenges that we have to get food into space. For example, surface system strategies. How do we grow food on Mars in a greenhouse or controlled environment? What type of automation technologies do we need to have in place? I discussed how great documentation is really vital for open source projects, how it empowers people in a community to take part in your technology, to take part in your movement. And what was very cool was how curious the NASA engineers and scientists were about our experience at FarmBot. They really want to learn how to engage people all over the world, everyday people in their garage, at their makerspace, to get excited about growing food in space and space travel in general.
Unlike the rest of these folks, we have not used open source much at all. But from this meeting, I've learned the value and importance of open source. And working with FarmBot particularly, I found that we can go to this community of people we've never approached before and ask them for help.
3, 2, 1.
So this has been a great opportunity to learn about how to access that. Because we had never accessed it before.
I mean, NASA is an agency of the U.S. government. We're funded by U.S. taxpayers. So in essence, all of the data that is created with taxpayer funding should be available to taxpayers, should be available to the world. We're moving in that direction. We're trying to make things more open source and more available. And we need to learn how to do that effectively. And so talking with groups like the MIT Open Ag Initiative, like FarmBot, who do this successfully, has been really instructive for us.
Somebody who's developing a piece of software or a new tool for FarmBot, they might see their innovation be picked up by the NASA engineers or be used in conjunction with something from MIT Open Ag, and eventually that could go to the International Space Station or the Moon or Mars. I think that's really exciting.
This just opens up the world in terms of being able to have common people who are interested in the topic commit and contribute. It's just such a win-win.
By sharing something on the internet, who knows who's going to pick it up and what they're going to do with it? Who knows who's going to get in touch with you because they think your idea is really great?